Hey guys, welcome back to another video. Today we're going to be just cleaning up some of the backend and getting everything prepared for the next part. We're also going to be optimizing the game for mobile usage, and I'm just going to show you that now. So you can see here I've got a screen recording of my mobile phone that's actually connected to a HTTP server that I'm running, and this is serving the game over my local internet. So I can just log in. And you can see that I can start moving around. I can also register for an account on my computer. You can see that I log in. I can move around on my mobile. And I can also move around on my desktop application. And finally, if someone's playing on the web on their computer as well, I've got that demoed up here. So I can log in, I can register as someone else. And then this person can join in as well. And you can see that everybody's screen is updating no matter which client you're using. So this is a truly cross-platform game now. You'll also notice that if I log out, so this is me here up the top. If I log out, and if I just log back in again, you'll notice that I spawn again right where I left off. And you'll also notice that I appeared straight away for the other clients on their screens. And you'll also notice that when I logged in, everybody became visible to me straight away. So you'll notice that that fixes the 3 bugs that were mentioned at the end of the last video. I can also chat now on mobile because I've added this send button here. So I can also click this send button on PC. But on PC I can also press enter. On mobile, there's no enter key, so that's why we've added the send button. So I can click into this chat box here. I can type a message. And then I can click done and then send. The experimental phone keyboard is not perfect, but I believe that this is being worked on at the moment by the Godot team. So don't forget, as always, you can come into the official GitHub repository. Link will be in the description. Come to the releases section, and here you will find the end of lesson 3. So if you want to start following along from this video, then you can download the source code for the end of lesson 3 and merge it into your game project folder. You'll need to retain your virtual environment if you had it set up, or you can set it up by following lesson 1. And you'll also need to run any database migrations. You can find details about how to do that in lessons 2 and 3. But if your database migrations get really messed up, you can always just delete everything in the migrations folder except for init.py. And you can also delete the db.sqlite3 file and just try running an initial migration again. And that should bring everything in line. And again, if you want to follow along and copy and paste code from my blog, come to tbat.me/posts and you'll see a Godot Python MMO Part 4 blog appear by the time that this video is uploaded. Well, as promised, I'm going to be showing you how to complete the homework lesson from last time. So here's just a quick reminder of what we need to fix. So when you log in, you can move after you've spawned in the top left corner. Then if you log out, log back in again, you'll notice that you spawn right back in the top left corner. And the hint was to use Django's .save method somewhere in the code to try to save the position between logins. So let's have a go at that now. So yeah, the problem stems from the fact that we aren't saving the actor's position to the database after they move. So come on into the server folder and protocol.py, and here in our update position function, we update the actor's position, and we return true only if the position was changed. So come on down to the part where we actually change the position. So we're changing the actor's instanced entity X and Y coordinates. And all we need to do is, after we've done that, we just need to save the instanced entity model to the database. So we can say self.actor.instancedentity.save. So now we're saving the actor's position to the database every time he moves. It might also be a good idea to do a final save of the actor on the onClose function, just so that if the player disconnects, the database can be sure to do one final save so that there's nothing lost. So we'll just do a quick check to see if the actor exists, because the onClose method can be fired if they are still in the login state where the actor doesn't exist yet. So we'll just do a quick check to see if they do exist, and then if so, we'll just give them a quick save. So now we've got the actor's information being saved to the database correctly from the server side. We just need to make sure that the client side is correctly initializing actors given their positions. So come on over to Godot and open up actor.gd. We're going to need a new member variable, so we can just put that down here somewhere. We're going to call it initialized position, and it will be a boolean initially set to false. And this will help us keep track of whether or not we have initialized the position for this actor. So in the update function, just after we set the server position, so we're interpreting the instanced entity's X and Y coordinates, and we're saving that to the server position member variable. Just after that, we can add the following code. So if we have not initialized this actor's position yet, then we're going to do that now. So we set it equal to true. And then we just let our kinematic body 2D's position be equal to the server position we just calculated. If they're a player, then we'll also set their target equal to the server position. So we can save that. Note that if we try to run the game at this point, we do get an error that just says invalid index position. So this is just because at this point, the update function may be called before our kinematic body 2D has been initialized. So our body member variable will actually be null. So there's a couple ways we can fix this. I think the best way to fix this would be to make sure that the update function is only called after the model is ready. So come on into model.gd and we'll just change the behavior slightly. We're going to create a new dictionary called initial data, and on the init function, we're just going to set initial data equal to this initial data. But I kind of want to rename the parameter to this function just so that we don't get confused. So I'll just call it init data, and then the member variable will be called initial data. So that's the only change that we're going to make to model.gd. In actor.gd now, because the update function doesn't get run on initialize, we need to run it ourselves. And remember, we wanted to run this only after the actor is ready. So in other words, we want to run it only when all of these things have been initialized. So the way to do that in Godot is to create a _ready function. And then this function gets fired only when the actor is ready. So once that occurs, then we'll just run the first update with the initial data from the model. So this is inherited from this. So we can save that and try running the game again. And you can see we spawn where we last left off. If we move again, so now we're sort of more towards the upper middle of the game window. You can see we spawn right back where we left off. So also remember problem number 3 from last time. An invisible actor who suddenly moves will appear to come out of the top left corner and move to their proper position. So when you first log in, if there are other players in the game already, they will be invisible to you. But if they do suddenly move, they will become visible, but they will shoot out from the top left corner. But note that now that we've fixed this bug, bug number 1, we've actually already fixed bug number 3 as well, so that should not be happening anymore. They will still be invisible to us when we log in, but they won't be shooting out of the top left corner. So let me show you that. So notice that this guy on the left is already logged in, and when we log in with the guy on the right, you'll notice that this guy here, he should be here, but he's currently invisible. If I move this guy on the right, this updates correctly on both screens. And previously, if I move to this guy on the left, he would come shooting out here to his target. That would be what this player sees. But if I do that now, he comes out of the correct spot. So that's problem number 3 also sorted. So the last problem is that when someone new joins, you'll see them pop up straight away, but they won't be able to see you. So in other words, existing players will be invisible to new players until they start moving. So let's focus on fixing that bug now. So this one is a little bit trickier, but I think we can handle it. So we need to first make sure that newly connecting clients are broadcasting their model to everyone who's already connected. So currently new players, when they come out of the login function, they are only sending their model data packet to their own client. We need to make sure that we're telling everyone about this. So we need to change this send client to a broadcast. We also need a way of keeping track of all the other players that our player knows about. So we're going to create a new member variable. It will be a set of protocols called self.knownothers, and reinitialize this to just be the empty set. So this set will hold all the other protocols who have made themselves visible to us. So in the play state, underneath where we process model data packets, we're going to add a bit of logic. We're going to add a bit of logic for making sure that we add them to our known others list. And if they're not known to us, then we send them some information about ourselves so that we, in a way, introduce ourselves to new players. So yeah, if we receive a model data packet, we send it to our client straight away, but we also check to see if they're not in our known others set. And if they're not, then we will send them a model data packet about ourselves, and then in turn they will process our own model data packet and send it to their client. So when they log in, anyone who's currently on the server won't be invisible anymore. They'll actually appear in their correct spots. But we'll also add them to our known others list, our known others set, so that we don't do this more than once. So we do this once when a new player connects, and we never do that again. New players who connect, they will get models from everyone. So they'll process model data packets for everyone who was in the server when they joined. They will also, because everyone won't be on their known others set yet, they'll send themselves to everyone again. But they'll only do that once. So there are slightly wasteful packets being sent with this approach, but I think the simplicity of this approach sort of outweighs the potential drawbacks. But a good exercise for you would be to try to make it so that newly connecting clients don't send their own model to everyone twice. Ideally, they should only be sending themselves once. So that would be a good challenge. So yeah, it turns out that that's all we actually needed to fix problem number 2. So let me restart the server and show you. So I've logged in with my guy on the left. So now a new player connecting, he should be able to see this guy straight away. And there we go. He sees him straight away. So that's bug number 2 fixed, and that completes all of the bugs that were in our game at the end of the last video. So you might notice that all of these packets that we're sending, they contain a lot of information. The model data packets, they contain a lot of information that we're not necessarily using. So for example, when we move, we definitely want to tell the client that we've updated our position. So we should be sending X and Y if they've changed. But we don't necessarily need to be telling it, the entity's name. Again, we don't need to tell the client that so many times per tick. And we don't need to, tell it some of these other things as well. And especially once we extend our actor model to support things like avatar ID and maybe some other things, we don't need to be sending that every time we move. So it is slightly wasteful to be sending the full model every time. So to fix that, we're just going to spend a little bit of time improving that performance. And we're going to introduce something known as a model delta packet. So a model delta packet will contain only the relevant information that has changed, and also any information that is required to identify the model. So we need to include things like ID and model type, and we need to include the IDs and model types of any children. So for example, we would send this instance entity ID and the instance entity model type, and then anything that's changed. So we'd be sending just an X coordinate if the only thing that's changed is the X coordinate. So that way we can cut down on all of the data that we're actually sending and only send the relevant information to the client. So to do that, we do need a new function in models.py. So come on into models.py, and just underneath our createDict function, we're going to create a friend for him. So this is our new function called getDeltaDict. And you can see that we supply it with two model dictionaries. One is a before dict, and then one is the after dict. And this function will return a dictionary that contains all differences between the supplied dictionaries. So this dictionary will contain only the differences, except for if there's an ID or a model type key. So we need to send just the bare minimum amount of information to convey that this actor has changed. But we also need to be able to identify the particular model on the Godot side. So for that, we need ID and model type attributes to be retained. But everything else will be stripped out except for any differences that occur between this dictionary and this dictionary. So we just start by defining the thing that we want to return at the end. So we're going to construct a delta dictionary, and then we will return it at the end of this function. So what we do is we grab the intersection between the two key sets. So this is the before key set, and then this is the after key set. And in Python, the way to look at all of the things in common between two sets, you can use the ampersand symbol. So we're just looping over all of the keys that are in common between these two dictionaries. I'll just get rid of this debug statement that I was using before. So yeah, we just calculate the values of the before dictionary and the after dictionary when we're looking at the same key. So we get the before and after values, and then we just check to see if it's an ID or a model type key. In that case, we just want to add it to our dictionary. We just want to add it to the dictionary that we're going to be returning at the end. We also check to see if the value before is equal to the value after, so there's no change at all. Then we're just going to continue. We're just going to skip the rest for this loop, and then we're going to look at the next common key. Otherwise, if we get this far, then that means that there is a difference between the before and after values. So we're going to start looking. First, we'll check to see that the value is not a dictionary. So we just want to sort of base case check to see if we have a difference in some sort of primitive values. And if so, then we'll just choose to take the after value. So the after value will go into the delta dictionary that we're returning. So this is sort of the base case. But otherwise, if the values that we're looking at are indeed dictionaries, then we need to sort of recurse in and get all of the deltas for that sub-dictionary. Because remember, our models can have submodels, which means our dictionaries can have nested dictionaries inside. So we need to account for that by recursively stepping in to each sub-dictionary and running this function again with the new dictionaries. And at the end, we just return our delta dictionary, and that will be it. So next, I think it's appropriate to rename our packet to model delta packet instead of model data packet. And just note that a full model data could still be known as a delta. It just contains all of the information. So we can still send full datas under this model data packet, It's just that we can also send partial data. So a more adequate name would be model delta packet, just to remind ourselves that we can send a partial data. So the easiest way to rename this thing is to come on over to the left on Visual Studio Code, click the magnifying glass, and then in the search field, type model data, and then in the replace field, type model delta. And then you'll just click this replace all button. And you'll get a preview of the changes that it makes as well, so that you can make sure that it's not changing anything that you don't want it to change. But in this case, that all looks good to me. So we'll just click replace all. And you can see it's renamed our action and our model data packet to model delta packet. Now, just as a quick sanity check, we can try to run the server again. Come on into Godot, and you'll notice that it's saying that the following files are newer, because when we did the find and replace for the whole project, we also changed some of the code in main.gd. So just make sure you click this reload button, and that will bring the new changes in. So open up main.gd. If you scroll down to the play state, you'll notice here it says model delta. So if we click run, we should still be able to play our game the same as before. And you can see everything still works. So that's a good sign that we can continue making our optimizations. So on the server side, the only thing we need to do left is to modify the tick function of protocol.py. And we need to only broadcast the delta if we update the actor's position. Here we see the tick function. And here we can see that when there's no more packets to process, if we're in the play state, and we'll try to update the player's position, and if the position was correctly updated, we'll broadcast a model delta packet containing the full model dictionary. But here, because we're only updating a position, we don't need to broadcast the full model state. We just need to broadcast the delta. So we need to calculate the before and after. So before we try to move, we'll just save a variable called actor_dict_before. And we'll set that equal to our models.createDict on our self.actor. So that's the full model state before we move. And then after we move, we can create another variable called actor_dict_after. And here we're just calling the same code, but this gets called after we move. So this will be different from this. So because these things are different, we can use our new function that we've just made to create a delta dictionary, and we can just broadcast that. So this line here now says we're going to broadcast a model delta packet, and the dictionary that we're supplying as the payload to this packet will be our get delta dict when we're supplying our before and our after. We can save that. And that's all we need to do on the server side. You'll notice that we haven't used our new function in some of the other areas that we're sending a model delta packet. So there's 3 places we're doing this. So there's this place where we have modified the behavior. We also do it when we initially log in, but we want to keep this sending the full model state because when you log in, the client doesn't know anything about your actor potentially. So there's no way that you can just send a partial information and have that sync up nicely with the client. So here we continue to send the full information. And likewise here, this is the code that we wrote earlier in this video. This is the case where if someone new joins and we want to introduce ourselves to them, so to speak, we also need to send our full information in that case too. So that's the server side done. Now that we're potentially sending partial information, we need to tell Godot to interpret the model updates slightly differently, because there are some things that we were assuming before that we're not allowed to assume anymore. So open up actor.gd, and here the first thing you see in the update function is we're setting the instanced entity equal to the incoming model's instanced entity attribute, but we might not be able to assume that a delta model has an instanced entity attribute, and we might get a key error here. So unfortunately, what we need to do is make a lot of if statements. So we can use the .has function on Godot's dictionary type. We can say if new model has instance entity, then we're allowed to assume all of this. And likewise, we might not be able to assume that an instance entity has an X and a Y coordinate. So we need to say if it has an X and it has a Y, then we can do all of this. We might not be able to assume it has an entity. We need to say if it has an entity, then we can do all of this. Just for ease, we'll make a new variable called entity, and we'll just set it to this thing. And then we can replace this with that. But as you might have guessed, we can't assume the entity has a name. So we need to check before we do anything. So that's unfortunately what we need to do. I guess that's the cost we pay for a bit of performance. But there might be a way that you can refactor this code and make it a bit nicer. Well, it turns out that's all we need to do. So let's try running the server again. And let's try running the game. So you can see that if I log in, the initial model delta packet we receive is the full data. So it contains user ID, instanced entity, X and Y. It also contains the entity and the name of our player. But when we move, you'll notice that the only thing we're sending is the true delta. So we still keep the actor's ID and we keep the actor's model type. And then this is where we step into the instanced entity sub-dictionary. And you'll notice that we're keeping the ID and model type, but the only other thing that we're including is this Y value and this X value. And we're not including anything about the entity or its name or anything like that. So we're only sending the things that have changed between this time and the last time. And if I log in with someone else, you can see we're still sending the full model dictionary when we log in, but when we start moving around on this guy, we're only sending the things that matter. So this will reduce a lot of the network throughput, and as our models grow and contain more and more once-off attributes, this will dramatically boost the performance of your game. So definitely worth doing sooner rather than later. And just to show you sort of the difference, here's an example of what we were sending before we made this change. Every time that the actor's position was updated, we would broadcast this to everyone. And here's an example of what we send now. So this is just the delta information. So this would be in the case that your actor's only moving horizontally, but regardless, you can still see the difference in size between these two. So this particular example of the before, this particular example of what we would be sending before, this is about 223 bytes, and we'd be sending this every time our actor is updated to every single other person on the server, so that really adds up. So this was 223 bytes, and then this one here is only 138 bytes. It's not quite halved, but if our actor model was more complicated and had more fields, then this would be much less than half. So the next thing we're going to be doing is implementing what's called rubber banding. So you might have noticed that we never actually set the player's position to be equal to the server position, except for when we are just initializing for the first time. So you can see here, we're setting the body's position equal to the server's position only if we have not initialized ourselves. But in general, there's no real attempt to keep the client in sync with the server. So theoretically, if we played for long enough, you can't really avoid the client's position going out of sync with the server's position. And the server is calculating the position and sending it to the player in the form of the model dictionary. But the player, you can see the client is not making any attempt to interpret this mid-game and do any sort of checks to make sure that it hasn't strayed too far from the server's position. So we can do this. We can make it so that when the difference between the client's position and the server's position is too much, we can try to sort of autocorrect by telling the client to snap back to the server position. And this is why it's called rubber banding, because you have this sort of snapping back effect. And then you've probably experienced this yourselves on games when you have a bad network connection. The game's client can sort of snap you back to your last known position on the server. So this will be good just to make sure that the client doesn't go too out of sync and players won't be misled by where they actually appear in the world. But in practice, this should be rare if we are keeping everything in sync, which we are trying our best. So we're going to start out in actor.gd, and we're going to define a new variable called rubber band radius, and we're going to set that equal to 200 pixels. So this is the minimum distance you'll need to be away from the server's position to let rubber banding take effect. And then just here in the update function, we're going to add an elif statement to this initialized position if statement. So we're going to say else. So if we have initialized our position before, so this is going to be more of a true update step. So else, if the body position and the server position are more than the rubber band radius apart in length, then we set the body's position equal to the server's position. And that's it. That's all you need to do to implement rubber banding synchronization between the client and the server. We can save that. We can start our server to test this out, but it's going to be hard to test because in practice, you're never going to notice this unless you have a really bad internet connection and you've been playing for a long time and clicking around lots and lots to try to make it go out of sync. But otherwise, we're doing a good enough job keeping everything in sync. So we're going to have to sort of fake it and make it so that it goes out of sync. So we can change our client's speed variable from 70 to something higher or lower so that it doesn't match this 70 from the server anymore. So I'm going to change my client speed to 200, and this will force the game to go out of sync with the server. So if I play this now, you can see that when I start moving, I get snapped back to the server's calculated position of where I'm at. Every time I go more than 200 pixels away from the server's position. So you can see that working here. So I close that. So I'll just make sure that I set this speed variable back to 70, just to make sure that it stays nice and in sync with the server. Just another thing quickly, we're just going to quickly fix a very rare bug where the server can crash if it tries to send a message directly to a client who's just disconnected. So it is actually pretty hard to replicate this issue, so I can't show you, but I have had it happen before. So that's why I'm just going to show you how to fix that now so that it doesn't happen to you. So come on into protocol.py, scroll to the very top, and we're going to add a new import. So from autobahn.exception, import disconnected. And this is an exception that gets raised if we try to send a message to a client who is not connected. So that means that if we scroll down to our send message function, or send client rather, this is where we send a packet directly to our client. Here, Instead of sending this directly, we're going to put it inside a try block, and then we're going to check if we get a disconnected exception. And in that case, we're just going to print something to the server log. So couldn't send packet because the client disconnected. So now that shouldn't crash the server if it happens, but instead it'll just log a message and do nothing. So the rest of this video is going to be spent just optimizing the game for mobile. So you'll notice that currently there's no way for a mobile user to type a message and send it. And you'll also notice that when you click inside the chat box here, the client will think that it needs to go to that location because you've clicked. But we want to add a send button here so that people in mobile can click something when they want to send because they have no access to an enter key like we do. And then we also want to make sure that when we're clicking on UI elements, we don't want to move our client. So let's go ahead and make those changes now. So let's come on over to our chatbox scene, come into the 2D view, and this is our scene tree as we left it last time. But we're just going to add a new element to this bottom HBox container, and we're going to add a button. So now that we have our button node, we can add some text. So we're just going to say send. We'll save our scene. And now you'll see we have our send button here that our people on mobile can click. It's a little bit hard for people to press this button or press the line edit field, just because it's so close to the edge of the game screen. So what we can do is add a little padding to make it sort of more central, to make it sort of easier for people to press on mobile. And it'll just look a little bit nicer as well if there's a bit of padding. So what we can do is click on our VBox container node, come to the right-hand side inspector, and we're just going to set the margin. So we're going to set the left margin to about 20. And then the right margin, we can set to -20. So you can see that there has introduced a small gap on the left and right sides. And then we'll set the bottom margin to -20 as well, so that that's all away from the edge of the game window. If we play our game now, we'll see that that looks much better. And that will be much easier for someone on mobile to press. But you'll notice that we can't actually click the button and have it send our message. So that's what we can do next. And we'll still need to make sure that our player doesn't move to the location when we click a button or click the line edit. So we'll hook up the button now. So come to your chatbox.gd script. We need to get a reference to our button node. So we're just adding a new onReady var button equals get node, and we're just specifying the path to our new button node. On the ready function, we're going to connect our button pressed signal to a new function called button pressed. And finally, we're specifying our button pressed function to just call our text entered function with the input field's existing text. And that will in turn run this code, which will emit our message sent signal that main.gd can pick up on. So now if we test that out, we'll see that we can type a message and then we can press the button to send it. So let's just fix the last problem and then we'll wrap things up. So this is maybe the simplest fix you'll ever see. Inside main.gd, in the input function, this is where we're checking to see if we've clicked the button and we get our global mouse position. And we do this regardless. We do this for every input. But there is a way in Godot to make it do this only for what's called unhandled inputs. And an unhandled input is just an input that's not already been handled by some built-in thing, like focusing a line edit node or pressing a button. So we can do that here. We just changed the word input to unhandled input. And then that will run this code only if your input hasn't been handled by something else. So if we save this now, test it again. So you'll notice now you can click inside the line edit field and your character won't move towards it. You can also click the send button and it won't be picked up by the main script trying to move the character to that location. You'll just notice now though, however, that if you click inside this rich text field chat log, you won't be able to move to it because there's actually some sort of input that's trying to be handled by this chat log. So we can close this. And the way to fix that problem is you come into your chatbox scene and look at the nodes on the left-hand side. We want to select the VBox container, come down to the mouse section of the inspector, and then set the mouse filter equal to ignore. And then do the same thing for your rich text label field. Come down to mouse, filter, ignore. And what this does is it makes it so that the rich text label will be able to ignore any input events relating to the mouse, and it won't try to handle them. And then it can be processed by the main script's unhandled input event. So if we run the game again, you'll see that we can click inside the rich text field, but we still can't click and move to inside the line edit or the button fields. So now we want to test the game on our mobile phone. So to follow along with this step, you need to have a phone that has an internet browser, and it needs to have Wi-Fi enabled and connected to the same network that your computer is connected to. So the next thing you need to do is obtain your computer's local IP address. So if you come down to Visual Studio Code, and if you just stop the server by pressing Control-C, and we can actually clear this log, and we can actually clear this log by typing clear and then enter. And the command is slightly different for Windows versus non-Windows. On Windows, you can type this command. You can copy and paste this from my blog. So if we run this command, we will get my local machine's IP address. And if you're running Mac or Linux, you can get the same thing by running this command here. So I've got my IP address, so I'm going to copy that, come on into Godot, open up main.gd, and scroll to the top. And we're just going to find where we are connecting to the server. And we're just going to replace this 127.0.0.1. We're going to replace that with our local machine's IP address, and we'll save that. This means that when we run our game on another device that's connected to the same network, it will be able to resolve this address to our local machine and connect to the server that's being run by our computer. So now we're just going to re-export our game to HTML5 so that it picks up on this new change. So we'll come to Project, Export, click on HTML5. We want to make sure that the export path is index.html instead of client.html, which is the default. So it just needs to be index. And if you scroll down a little bit, you'll find the experimental virtual keyboard. Experimental virtual keyboard. This makes it so that you can type into the input fields on a mobile device. So you just enable that and then click Export Project. You want to save it in your HTML5 subfolder or whatever you've decided to call it, and make sure it says index.html down here before you click save. So now we can open up Visual Studio Code. We can run our server. So you can see our server is running. And now come to Client and right-click on HTML5. Right-click it and click Open in Integrated Terminal. And you'll notice there's a new terminal instance on the right-hand side. So this is our HTML5 folder, and this is our server folder that's running our server. We're interested in the HTML5 folder. We're going to start a HTTP server so that we can start serving our client export documents, and then we can connect to that from our phone. So just type this command, python-m http.server, 80. This starts serving up our game on HTTP port 80 from our local machine. So I can open up my phone and I can connect to my local IP address, which remember was, and this will be different for you, but my local machine's IP address is 192.168.20.15. And if I literally just type that into the address bar of my internet browser on my phone and click go, then you'll see that I'm starting to load into my game. And you'll also see in the HTML5 terminal, we're getting some things logged, like I'm getting the index and I'm getting some more things. So it is serving this correctly to my phone, and you can see my phone has now loaded the login screen. So on the server, I can see client connecting, and that's my phone's IP address. So I can click on username, and you'll see that the experimental keyboard loads up. So I can type in my username and my password. I can click login, and you can see I'm now in the game. So I can click to move, and I can even click inside this rich text field area, and I can also click in the line edit field. So the only problem is I can touch the line edit field if it's already focused, and I won't move to that location. So I can type something and press send. But if the text field is not focused, if I click into it, I'll start moving. And I'm not exactly sure why that is, although I'm sure if you spend enough time looking into it, you could come up with a solution. But just for the purpose of this video, I'm just going to call that out of scope for this tutorial series, so we can just sort of get on with the more important details. So I just want to thank you for following along with this lesson. If you want to download the code for this lesson, you can always come to the official releases on the GitHub and find this end of lesson 4 and just download the source code zip. So we're getting very close to the end of this course. In the next part, we'll just be focusing on allowing the user to choose an avatar during registration. And we'll just be prettying up the client side with some nice graphics. So the next lesson will be pretty chill. After part 5 is released, I will be creating some ad hoc lessons per request. You might have already seen the first poll that I've put on my YouTube. If you subscribe, you'll be able to see these polls more easily, and then you'll be able to vote for what you'd like to see in future videos. So yeah, check that you're subscribed, and I'll see you in the final of the core lessons next time, and then we can start looking at some more specific requests if you are interested. So again, thank you very much for watching, and if you had any questions or feedback, please don't hesitate to reach out either via the YouTube comments, or you can join the Discord server. So we already have 11 members, so we're still trying to get some more members, but it's the best place to ask if you need some specific help. So I'll see you in the next part. Thanks for watching. Take care.